Your knowledge of functions, what they are, what they aren't, what they look like, and how to evaluate them will definitely be tested on the ACT. So in this video, let's review the basics of functions. So what is a function? A function is a mathematical relationship where every input has only a single output. Functions will typically look like one of the following examples. So f of x equals x plus 3, or h of x equals x squared minus 2. You'll see that if we plug in any value for x in f of x, that we'll get exactly one output. So if we say f of 1, we'll get 1 plus 3, or 4. So we only get one output. If I say f of 1, I can only get 4. I won't get another value like 7 or 3.4 or I or anything like that. That's what makes f of x a function. There's something else called the vertical line test, which basically states that if you graph a relation, that relation is a function if no vertical lines intersect it at more than one point. So this is a great way of very easily checking if something is a function or not. So I have 4 examples here, and I have this vertical line. You can see the first example, which looks like a bell curve. If I take this vertical line and I drag it along different values of x, you'll see that I only get one output for y. That's what makes the first graph a function. On the other hand, in the second graph where I have a circle, you can see that if I take this vertical line and put it over various values for x, that sometimes I get 2 values of y. So if I put it right at x equals 0, you'll see that I get y values of approximately 1 and negative 1. This makes this not a function because of those 2 different outputs. In the third example, you can see that this is a function because if I drag this vertical line across, I only get one value for y every time I have a value of x. At the point 1, negative 1, you'll see that there's an open circle, which means we do not include that value. Whereas at the point 1, 2, there is no open circle, so it's safe to say that if this function were defined as f of x, that f of 1 would be evaluated at 2, not at negative 1. Finally, I have another graph which looks like a function for a while, at least for values of f of negative 3 all the way through approximately f of 2, because if I take the vertical line over any of those values, I'll get a single output. But once we get past x equals 2, you'll see that we fail the vertical line test because there are 2 points of intersection. Okay, let's move on to evaluating some functions. So I have 3 functions. F of x equals 3x plus 2, g of x equals negative x squared minus 5, and I have a graph of h of x. So let's do some evaluations. What is f of 1? So this simply means that we plug in 1 in f of x anytime we see an x. So we have 3x plus 2, or 3 times 1 plus 2, which of course is equal to 5. What about g of 3? Well, we have negative 3 squared, which is negative 9, minus 5, and we get negative 14. What about h of negative 1.5? So if we look at the x value of negative 1.5 in this graph, it looks like the y value is 0. So we get 0. Let's do some more complicated examples. What is f of g of 3? Well, we already know what g of 3 is. If we have g of 3, we get negative 14. That's the output of g of 3. Now what if we put that value, negative 14, as the input for f? Then what do we get? Well, now we simply plug in negative 14 for x in the equation 3x plus 2, and we end up getting negative 40. So anytime you have something that is in the form f of g of x, first you need to find the output of the second term and use that as the input for the first term. So what is h of f of negative 1? So let's take f of negative 1. So f of negative 1 is equal to 3 times negative 1 plus 2, or negative 1. So now we need to take h of negative 1. And h of negative 1, if we look at the graph, looks like we get a result of 1. What about h of f of 1? Well, if we get f of 1, we get an output of 3 times 1 plus 2, or 5. And then we take h of 5, and you'll see that this graph is actually, it's not defined at h of 5. So we get undefined. Okay, what is f of x plus g of x? Well, we haven't done one like this before, but you can safely assume that you could add functions just like you could add anything else. So in this case, we would get 3x plus 2 plus negative x squared minus 5. And then we can combine the like terms. So that gives us with negative x squared plus 3x minus 3. What about the following? What is the product of f of x and g of x? Well, this looks like we just take 3x plus 2, and then we multiply that by negative x squared minus 5. And now we can do the FOIL operation. So 3x times negative x squared is negative 3x cubed. Then we'll take the outer terms. So 3x times negative 5 is minus 15x. Then we'll multiply the inner terms, and we'll get minus 2x squared. And then we'll take the last terms. 2 times negative 5 is negative 10. So if we want to rewrite this, we get negative 3x cubed minus 2x squared minus 15x minus 10.